Hello, everyone. Welcome to Brandforsk and this webinar presenting the research project ITM Data Exchange, New Frontier of Standardization and Support Reliability Analysis. And my name is Mattias Delin, and I'm the Research Director of Brandforsk, the Swedish Fire Research Foundation. And this project that we have been a co-sponsor to is been done by the Fire Protection Research Foundation in the US. That is kind of colleagues to us, quite similar organization as Brandforsk, and we try to collaborate as much as possible. This work will be presented by Victoria Hutchison and Bart van Leeuwen. Welcome. Can you please join us?
Good afternoon, everyone.
Hello, everybody.
Hello. Very welcome. Good morning, Victoria. Good afternoon, Bart. So, Victoria, can you tell us a little bit about yourself?
Sure. I'm a research project manager at the Fire Protection Research Foundation at the National Fire Protection Association. So like Mattias said, it's very similar setup to Brandforsk, but we're the independent research arm of the NFPA. And I manage a lot of research there on data and analytics, reliability of fire suppression systems, fire alarm systems, and then also in emerging technologies as well, and have a background in fire protection engineering and have done some previous work on inspection, testing, and maintenance and system designs.
Excellent, excellent. Welcome. And Bart, who are you?
I'll introduce myself with my multiple hats and helmets. I'm here representing NetEdge. We're a data integration company from the Netherlands. We've been around for more than 25 years, working mainly the last 12 years on graph technology, a lot on standardization, data standardization. I have a position at the Free University of Amsterdam in the human-centric data science group, where we look at how humans can interact with AI and machine learning, etc. And I have more than 25 years of practical experience at various fire departments as a firefighter in the Netherlands.
Very good, very good. Welcome. And a few words about Brandforsk. If you are not familiar with us yet, we have a vision, a fire-safe society built on knowledge. We develop and communicate knowledge, mostly research, and with the aim to limit the negative consequences of fire in the society. We started in 1979, and since 2 years back, we are a foundation. Everything that we do is financed by our supporting organizations, and this makes us a collaboration between many parts of the society because our supporting organizations are all around Sweden. The funding this year is about 650,000 euro. We use it for research, of course, and also on result communication to spread the knowledge so that it can be used and implemented. We also have a research school for practicing fire safety engineers in fire services. They are part-time PhD students during 4 years. And we have scholarships for students. And these are our supporting organizations this year. And thank you very much if you listen to this. And if you are listening to this and are not yet a supporting organization, please consider the possibility of becoming that. And the program today, after this short introduction, we will get a presentation from the project, about half an hour long. And after that, Bart and Victoria will give us a live demo of the data model that they have made. And we will have time for questions and discussions, and you can write your questions in the Q&A. And now let's go to the presentation of the project.
All right, welcome everyone to the ITM Data Exchange Model webinar hosted by Brandforsk. We're going to talk about kind of a new frontier of standardization to support reliability analyses for fire protection systems. I'm from the Research Foundation and I'm joined by Bart van Leeuwen today. And first of all, I want to just thank our sponsors, one of which is Brandforsk. So we're very thankful for the for the generous support of all of our sponsors here today. So I just want to recognize and appreciate them. So first, I'll let Bart introduce himself with a little bit of his background.
Hello, my name is Bart van Leeuwen. I'm from NetEdge, from the Netherlands. I wear multiple hats and helmets, as I will explain it. I did this project on behalf of NetEdge, a data company. We've been active for more than 25 years in data integration, but I have a strong background in the fire service. I have more than 25 years of practical experience with firefighting, and I hold a position at the Free University of Amsterdam in the Human-Centric Data Science group as one of the guest lecturers.
Thanks, Bart. And my name is Victoria Hutchison. I'm with the Fire Protection Research Foundation at the National Fire Protection Association in the United States. I'm a research project manager there, so I manage a large portfolio of research projects from emerging technologies and the fire hazards of those, all the way to data collection and analytics, and how we can leverage that to make decision making. Also focusing on fire and life safety systems, how we can improve reliability and the effectiveness of those systems as well. My background is in fire protection engineering, and what we're going to be talking about today, inspection, testing, and maintenance. I have some past experience in that type of work as well as, and some system design experience. So with that said, we'll get started here. This is a look at the agenda. So we're going to cover kind of the background of the ITM data initiatives that we've been conducting at the Fire Protection Research Foundation. We've been doing some work on this topic for the last several years. It's really of a lot of importance to the NFPA standards community, particularly. So it's this project that we're doing. It's focused on impacting the NFPA standards, but it really has a very broad and global impact and can be applied to a variety of different other initiatives and standards as well. So we'll cover the research project goal. We'll give you some background on kind of the history and kind of defining what a graph data model is, which is what we've developed. We'll go through the preliminary data model that we've developed for inspection, testing, and maintenance data. And then we'll go into next steps. And then once this presentation is wrapped up, once we're live with you folks, we will walk through a demo of what we've developed here. So just getting started on the background, just to define what we're talking about here, ITM data, it's any kind of data or information documented during inspection, testing, and maintenance activities on fire protection systems. So we're talking about sprinkler systems, fire alarm systems, fire pumps, all of those types of systems are kind of within the scope of this, but it's really those activities that are being conducted to ensure that these systems operate as intended when they're called upon. So the data coming out of those activities and that documentation. Why are we interested in that? This information can really be transformed into knowledge of system or component performance when you are able to take that raw data, consolidate it, and do some form of analysis with it. And once you have that consolidated and analyzed data, there's the ability to inform decision making on how often you should inspect your fire protection systems. What is the risk acceptability? Can we go from more of a prescriptive strategy to a performance-based strategy in terms of making sure that our systems are always functioning and that we get the kind of the best cost benefit for these activities and performance. So going a little deeper on why this is important, the reason that this data has value is that we have the ability to reduce risk if we have insight into our system performance. We have objectives of minimizing system downtime, increasing insights into system performance, and then being able to take that information and make evidence decisions off of that. But in order to reduce the risks, we need to be able to predict when the system is going to fail or when it's going to not perform as it was originally intended. But in order to predict failures, we need algorithms, we need predictive analytics that's based on historical system performance to be able to predict when the system might fail. And this is something that's used fairly regularly in industrial systems as well, in terms of predictive maintenance. But in order, for those algorithms to work, we need statistically significant data set that's of good quality, that's standardized and consolidated for analysis. But in order to get the data to feed into all of these other buckets here, you also have to get permission from the owner, or in order to use the data for analysis. So there's a lot of pieces to this, all of which was many of these pieces we've been working on in this ITM data exchange model project, largely focusing on developing a data model to help standardize the format in support of other analysis is kind of the focus of this study that we're working on right now, collecting data, seeing what the diversity is, and developing a data model that's representative of what's out there. We have done some past work where we've developed some predictive analytic algorithms that can be utilized once we solve part of the issues with the data. And then both the consolidated data and the algorithms could then be used in the future, ideally to inform frequencies in codes and standards, or just risk-based practices at different facilities. So really, there's hundreds of different types of inspection, testing, and maintenance activities done on extinguishers, sprinklers, fire alarms, fire pumps, you name it. There's plenty of them that go on around the world on this. And what we're wanting to do is take the information from these activities and let it feed into this evidence-based or risk-based decision making. But there's some pieces in there that still need work. So that the first challenge is that all of this data and this information, it's in thousands of different forms, thousands of different formats, and no single inspection report, it seems like, looks the same. I think Bart will talk to that a little bit more. Of every sample that we received looked differently. The names were different. The format was different. So it's not easily combined. Sometimes you'll see it in a PDF form, something along the lines of this. Sometimes it's on paper, not even digitized. And sometimes you get a very extensive spreadsheet like this, coded, specifically for that user. But that's only kind of the first problem. After you have all these thousands of different forms, but then you have to, take the tools and be able to consolidate this data in order to do something with it. And once you have consolidated data, then you need to perform the analytics on it to get some insights and information that you can then start making decisions off of. So kind of the key problem to date has been in this central area, which is really that data standardization piece that is really the challenge so far. But what we're focusing on in this project specifically is not necessarily on the consolidation and analysis particularly, but more so on standardizing the format, standardizing the data itself. So we're developing a data model to help with that piece. And this is a quote that really kind of tells the story of where we want to go, but where we are right now, right? The road to AI, or artificial intelligence, goes through IA, information architecture, and that data model is a critical piece of that journey. So the project goal, the Fire Protection Research Foundation released a request for proposals for a project that had a goal of developing a data model that is flexible, extensible, scalable, in support of the collection, analysis, and exchange of ITM data. So now I'm going to hand it over to Bart to give some of the background on what a data model is, and then also what we've developed in this project. So Bart, take it away.
Okay, so before we go into sort of the depth of the ITM data exchange model, we first need to talk about what is a data model. And data models don't facilitate cooperation. It's the other way around. To share data, you must share a point of view, and data is the expression of a point of view. And models make existing shared point of view more efficient. So within the realm of ITM, there has already been a shared point of view of what is important for ITM inspections. or inspection, testing, and maintenance, but how do you create a data model that allows you to share this in a data way? So we decided when we signed up for this project to use the graph data model. And the reason for that is that it's a super flexible model. And what I will do is I'll give you some introduction of what the graph data model actually is. So if we look at how computers are organizing their data currently, there's a lot of historical legacy. So previously, if computers needed to do calculations on memory, that was a very very expensive operation in the context of time. So it took a computer quite a lot of time to be able to use different pieces of memory to get to the results it wants. So a lot of the methods we currently use for organizing data is on how a computer sees memory. So how does a computer sees memory? Let's assume that I want to go to the 4, the orange 4 on the right side of this. The computer uses a method of using two arrows on defining the metrics of where it needs to get this data. And if you look at this, then you'll start to recognize that the way we use Excel spreadsheets is more or less like how the computer sees it. And the idea behind the predecessors of Excel was literally, can we make a computer program that acts like the computer and as such is really efficient? So what we are left with is not so much that it's the most efficient way of doing things for a human perspective, but more how can a computer be optimized to do it really quickly? Now with the more powerful computers nowadays, this actually doesn't really hold true anymore. It's not so relevant. So what we've been left over with is the traditional data modeling of columns and rows, because that's how the computer sees memory. And if we would do an ITM inspection, we end up with a table like this with an inspection and a test and a maintenance. We talk about location, stores, and dates, et cetera, et cetera. And to optimize memory was expensive, what people started doing is splitting this up in different tables so that you don't have the duplication of so much data, and you can do this almost indefinitely. And that's what you end up with Excel spreadsheets, which have the different tabs at the bottom, where one tab is actually referencing another tab through a column and a lookup, et cetera, et cetera. We're still organizing our data internally as humans on a way that is relevant and easy to use for computers when they were slower and more expensive to do all this processing. So what we ended up with is a computer optimized representation and originally drafted for optimization. How can we make this as fast as possible? The data is all on content level. Tables are organized around domain concepts. So you have a table on inspections, you have a table on maintenance. And to really understand what this tells you, what's in the various tables, you need to understand the domain. So domain specific knowledge is needed. And how many times haven't you received a spreadsheet that you look at the different tables and columns and like, I have no clue what this is about, and you need to call the sender of the spreadsheet to actually help you. And we had the same problem during this project when we got these spreadsheets. So is it all bad? No, this method is really well suited for well-regulated domains, for banking, for example. And there's a couple of others where this works. But there is a couple of issues. So there is a tight coupling between data and applications, because the application using these tables are not really capable of reflecting changes to the data model. So if the data model changes, the application needs to change. And the more complex we create these models, the more poorly they perform, even with modern computing. And the Facebooks and the Googles of this world are actually solving some of these problems as well with graph technology, because the traditional way didn't work. And you have a table per concept limitation. So you have one table for inspections, one table for maintenance, one table for testing, and some for addresses, et cetera, et cetera. And if you want to have multiple things in one table, the multimodality is really hard to implement, and it makes the applications really complex. And as such, it makes sharing data really hard without the actual domain knowledge. So it might work for a specific application, but for the purpose of the ITM project, where we really wanted to share data and combine data, this is really problematic. And there's some other issues with data modeling like this, and that's these columns. So what is location, and what is building, and what is an item, and what is a scan, and And what is the numbers in the location? And what type of dates are we talking about? Is that the first date in the column, is that the 10th of September or the 9th of October? So if you do not have any clear data definitions in there, it's really problematic on encoding dates and standards and locations and the terminology. What are we actually talking about? What are the definitions of the terms used in our data? So instead of trying to create a data model in the traditional way and sort of being sure that we ended up with the same problems at the end of the project, we decided to go for the graph model because that has a different approach. So what if we look differently at the way we organize data? So if we take this specific single inspection at this store, what you'll see is that if you would look at this, you need some sort of internal knowledge to be able to understand what the relationships between the various items is and to draft the story out of it. Interestingly enough, if we humans communicate information, we tend to do that associative. We tend to do that in stories. So if we take a narrative out of this inspection, we would say on October 9th, 2020, we performed an inspection, record number inspection 1 at a store located at 10,145. We inspected the smoke detector with ID 385682, which passed, and a CO detector with ID X44372, which failed. This is a story, and this is, if you share that with somebody, they might actually understand it better than just the simple tables we looked at it previously. If you now would sort of let a 4-year-old kid create this narrative, it would be the simple sentence. We did an inspection. It was on the 9th of October. The inspection was at a store. The store is located at, et cetera, et cetera. And we can actually grammatically break this down and say, okay, one is an inspection. It was on a certain date. Has a location. The location is actually a store. The inspection inspected a number, et cetera, et cetera. And we can put that in tables. We can make that subject, predicate, object. And now we have a set of statements which actually describe the whole inspection in a statement level. And if you look closely, you'll see that at some points, the subject and the object can actually be interchanged. So at some point, the object is the number of the location, but in a second statement, it's actually the subject. And that is what the graph concept is about. So if we would draw this out, it would just look something like this, where there is a relationship between the nodes, and these relationships is what we call edges. So now that we have created a different form of recording this, instead of creating different tables, we can express everything in simple statements. We're still not there yet, because we have a new form, but we have the same problems, because what on earth do all these predicates mean there? Because this is still open for discussion. So how can we solve that problem? So if you would look at my business card, and this is not a shameless plug, the question is, what would be the unique identifier on this business card? And that's a type of unique identifier we use all the time. And I can assure you it's not my name, especially in the Netherlands. This name is not unique by far. The thing that is really unique is my LinkedIn URI. If you would go to this URI, you will find me, nobody else, unless my LinkedIn page gets hacked. But that aside, this is my unique identification. So can't we use this to uniquely identify terms and concepts in our data models? So that would look something like this. So what we create, if we create URIs on the predicates, that would mean if we would go to any of these URIs, and these are shortened to fit better in the tables, we could actually find out what that thing actually means. But more importantly, if multiple people are using the same URI, they are talking about the same concept. If they use a different URI, they obviously talk about a different concept. And we can go a step further and basically use URIs for everything. That would mean that other people can actually refer to our inspection or our location or our, for example, smoke detector, all through URIs. So then we put URIs everywhere, and the middle ones, the predicate, that is actually where a data model lives, and that is what we have done for this project. So obviously the idea is, okay, is this something that Bart made up himself? No, this is actually a free and open standard which is broadly used, which is called the Resource Description Framework. I will not go into too much detail about this. And I actually, for the project, we did a 30-minute presentation on this whole subject where you can find more information on this. What is the resource description framework? It's not a file format, it's multilingual, and you can serialize it in various formats, in Turtle, in JSON-LD, in N-triples, and well, officially still in RDF-XML, but I wouldn't do that. And it's a standardized way of expressing these triples and dividing these relations in a graph model. And if you put this on the web, so the actual URIs are dereferenceable, we would be talking about linked data. And we use some of the concepts for linked data, especially for the data model, that at some point this can be dereferenced so that you can actually find what this is about. So what is linked data? Linked data uses the concept and technologies of the web to describe the world. And this is one of the former W3C staff members, was proud, no acronyms, no tag terms, one tweet. So where does linked data come from? Where does the concept come from? This is a paper by Sir Tim Berners-Lee in March 1989 at CERN, where he was battling his problems with finding information in the systems at CERN, so the research systems at CERN. So he created a paper which is called Information Management, a Proposal. And the fun part is that his professor at the time wrote at the top, vague but exciting. The cool thing is that this document is actually the blueprint for the web as we know it, as we use it nowadays, and how we actually came to watch this this webinar where you found the announcement. It's all on the web based on this paper from 1989. And if you look at his idea of how this web should look, you can find this graph model where there are relations between documents and items. And if you go to Wikipedia, you will actually find a document with links to other documents which are related, etc., etc. That was the initial idea of how the web should work. And as I said in the presentation, the video we recorded for this project, which is available on the project website, which we share later on, there's a more in-depth presentation about this topic. So what are the advantages of graph models and the linked data? The metadata is in the data. So the data has the data model with it. Instead of that, it's separate and you need to go and look somewhere. It's reference data. And if you use the URIs of your organization, for example, the data will actually emit authority. People can actually see, and in the case for this project, that the data model is hosted at nfpa.org. So people will have some sort of authority from that data. And the data stays at the source. So people can use and publish their data at their own domain, and you can point to it and relate to it. You use uniform identifiers, and you can connect multiple data sets through URIs, and we can show that in the demo. It's machine readable, it's suited and intended for data exchange, and it's really agile. It's super flexible. It's really easy to change any of these data models. So that is sort of a background on the graph data model we used. So what did we do for the ITM data model, the preliminary ITM data model? So what informed us? Throughout the project, and it was in the project proposal, we had a couple of focus groups meetings specifically at the NFPA 25 and 72 users on data availability, the existence data models, how data sharing was done, data quality. We looked at existing ITM data structures, and then we found out the NFPA 25 was never created with data collection in mind. The main purpose was to make sure that if you follow NFPA 25, it will actually make sure that your fire protection system is operating well and that it does what it needs to do, but not that if you follow the NFPA 25, you have a proper data collection. And that's what we saw in the available data. It was a huge variety of all sorts of formats, which made it really hard to actually go on with this project. Then we did a literature review on global best practice for data sharing. We looked at NFPA 951 FAIR data, the ODI open data standards, and W3C data on the web, and several others, which informed us, okay, what would be needed if you want to share data for research purposes. And we looked at a set of relevant existing data standards, which I'll explain a bit more later on. So what is the problem, especially for the NFPA 25 focused one of the current landscape of ITM data? It's unclear which party has what set of data. getting hold of the data, a lot of people told us, oh yeah, we can give you data, but actually getting there, so getting actually our hands on an Excel sheet was much more difficult than we anticipated. And due to the lack of standardization, it's really hard to understand what these spreadsheets are about because, well, what we discussed before, you have no clue what is in what column and how it relates. And another thing that we found out is that even though that individuals might say, we think it's a good idea that you get this data to do the research on, there are still legal departments who are not really fond of just giving away data. So in other words, ITM data is not findable, accessible, interoperable, or reusable. And there is a really great initiative in the research world, and that's exchanging data for research purposes, and that's fair data principles, a set of principles to ensure that data are shared in a way that enables, enhance, and reuse humans and machines. Also for this subject, you'll find them at the bottom of this link. We created a explanation of what the fair data principles would mean in the light of ITM data. So how do you make your data findable, accessible, interoperable, and reusable, where the reusability part is mainly about the licensing? How do you make sure that people can actually use the data for research purposes, for example? So then we started to create a data model, and the choices we made is that we basically figured out ITM is essentially about events. Every ITM activity is an event. It happened at a certain place in time. And as such, you're interested in timelines. And if you want to do predictive maintenance, you need to see when did certain actions on inspection, testing, and maintenance happen to predict when the failures will arise, et cetera, et cetera. And also some of the key elements within ITM are time aspects, frequencies and due dates for the next inspection, et cetera. So using a time-based core was the sort of the most obvious choice for this project. And we started to use the simple event model, was developed at the VU, which is very simple way of describing events and their place in time and the people who are related to that. And that's what we've started using as a base. So an ITM activity is an event. It has a time and place, and it can also be inferred from a side activity. It is a base class for item-specific activity, so fire pump activity, panel activity, and it has generic properties, item time, place, etc. So it's really easy to extend. So we do not limit it just to what's mentioned in NFPA 25. Any other ITM data model could be molded into making it fit for this specific data model. So the data model as it looks right now, we have a side activity with specific item activities, and these item activities can have multiple deficiencies, and they have an identifier, and they have a type of event that's been taking place in inspection, and testing, and maintenance, or all in one. That's all possible. And in the end, it will generate a report. It's important to note that this is sort of the structure as NFPA 25 wants it, but I think from what we've seen around the world, it's more or less the same everywhere. So how does this look? You can see here, this is one of the screenshots of one of the tools, which is going to be available. You see the SEM event on the left side, and the event types, and the inspections, and some of actions taken, and all the elements from fire pump or from a pump in general, and then you have a fire pump and a jockey pump. So things can be more specific in nature as well. So there's a hierarchy between the various items in this. And I would love to invite you to go over this data model and scan through it once it's published. Then we started to create data models as such. Okay, if you want to do a certain type of inspection, what are the required, the optional, and the recommended elements that are needed to make it useful and to make it actually help to be compliant to, in this case, NFPA 25 or 72. But this is beyond the structure which I showed previously. This allows you to set the constraints of what the data needs to look like before it actually can be considered proper ITM data. And then the second phase is here, that we actually started loading some of the data sets that we've got, where we got the license to actually do all the fancy things. And what you're looking at is a combination of data sets from different providers, all in one view. And we created the front end to do some statistics on all the data as well. And we got about 25,000 inspections in there from different data sets, which we could do some limited statistics upon. But that was never the goal of the project, to do the elaborate statistics that needed to be developed to make this data really useful. It was just, can we interconnect all this data? So now that we come to this point, are we done yet? Is it finished? Well, I think we've proven that by creating a graph data model and having the conversion pipelines, that we are able to pick various sources of data in a wide variety of formats and still create a coherent set of data on which various statistics and analytics can be performed. But it's a data model that we created as a company, and most of the standards out there are done by a community. So there needs to be a community process on top of some of the standards to help you create these data standards and maintain these data standards, because that was not in the scope of our project. And what we found out is that because the fire protection industry is so old, it's not per se a data-driven industry. It's not that they have a long history in being computerized or being automated. And so many people that we've talked to and we've met have no idea about data. So if you have these people who are absolute domain experts in fire protection systems and they need to create a data standard, you need to think about having a data steward or a standard data task group to help them provide a data standard for these kind of subjects. So that could be people like me who are not per se fire protection experts, but at least understand how data models need to be built and have this conversation. And the other thing that needs to be put in place, that if you have these data standards, that you allow vendors to have this data validation process as well. That a vendor says, oh, my system is compliant to data standard XYZ, and that somebody else can actually take their data and validate it to say, oh yeah, they are compliant, or say, well, it's not compliant, which could help with procurement processes or with legislation as well. So that are the three things that we think are important and that need to be picked up by the community when this project is finished. So with this, I hope that we have given you a quick intro on what this project was about, quick introduction on the graph technology. And in the live session, we will do a demonstration and we'll go through the demonstrator. And we probably will share the link as well, where you can look at the videos with more in-depth background on what we did for this project. So with that, I would like to say thank you. And in the live session, we will be open to questions and discussions.
Thank you very much, Bart and Victoria. And please welcome for the live demo. The screen is yours.
Okay, perfect. So this is the project demonstrator, and I think we can share the link later on where this is. Here you see all the links to the YouTube videos I talked about in the recording. The core concept of graph data models, the FAIR data principles, some background information on the project, some information on the data exchange model, and actually another webinar we did, which is probably more or less the same. What we created during the whole project is a project report, and you can read that, although it's still the living document. You can see what we've done here, all the background, all the references we've used, and some samples on how the data at the bottom needs to be implemented. We are still working on this, but this is coming to a final phase, I'd say. And then we have the data model itself, which is partly the vocabulary and partly the models. And the idea with the vocabularies is that we've tried to take all the items and properties from within, in this case for the project, the NFPA 25 and 72, and put them in classes according to the graph data model. And here for example, we have item activities, and we can see the various item activities that are available. And we quickly look up a pump, which is a generic item. And on the pump item, you can basically see the items, the properties that need to be described on a pump, or that can be described on a pump, basically, which are a pump. And then you have fire pumps, jockey pumps, missed system standby pumps, and these can all be extended by other pumps. And if you want to include information from other standards, then that could be potentially be wired up to this. The reason that we use this hierarchy in defining classes is that if there is different types of fire pumps, but you want to have some information by pumps in general, then this is the way that in a graph model you could say, oh, give me everything about pumps, and the system in the back end will figure out itself. Oh, then I'll need to combine the various types of pumps with their combined information to generate a report, for example. If we go back to the inspection, testing, and maintenance, I can give you a quick look in the components. And we're still under review of this part, so there might be things that will create some questions. There we go. So here are the classes, and here you can see the whole tree structure of the various items in the vocabulary that we've used. So this is only used to have the relationships and the hierarchy in the various classes and items and properties, but it doesn't say what you need to record to create a proper report. So that's where we would go to the models, get to the model page, and if we have the fire pump test model, then these are all the items that we say, oh, there are some required elements on a proper inspection of a fire pump. There are some recommended items on an inspection pump, and there are some optional items on a pump inspection. And what you can do from this is you can download the JSON template. And if I would hit that now, it will probably not show up in the shared screen, but it will. This would be for software developers to say, oh, if we want to generate a proper inspection report to be used according to this data model, the JSON should look like this. And you can also download the CSV template, and you can do it in a spreadsheet. But from an integration point of view, the JSON one is probably the easiest. And what we provide here is a validation method. And we don't have the JSON template, but you could paste a sample of your data, which you think should be correct. You could hit the validate button, and it will tell you that something is actually a valid pump inspection or not. So this allows vendors, if they would use a system like this, they would allow vendors to say, hey, we create a fire pump inspection data item, but does it validate according to what we've seen on the specs? So what we've done then after creating the data model is take sets of sample data we've requested during the project and that some of the participants actually gave to us, and we created a pipeline to convert all these various types of data into a centralized model so that we can do some dashboarding. It is important to understand that this project was not about doing fancy analytics on any of the data. It was only to demonstrate that with a centralized data model, we were able to go over various data sets and create a coherent data model over these data sets and then create a graph like this, sort of past inspections, failed inspections by type, and the amount of inspections. And what we have is 25,000 site activities, which we have gathered from the various data sets. So that proves that we are capable of going through various data sets who were given in the strange shapes and forms that they come, especially from the NFPA's 25 and 72 types, and still consolidate them, on top of which we could do some inspections. And we can look at these inspections from a graph perspective as well. And that would be, for example, if we say we want to know what's on a building, and here we have various buildings. So as a building owner, you could say, I have this building, and that has been a location for various site activities. And these site activities had various item activities, 47, and we could select a couple of them and then show them. And then we can look at, okay, what type of item activity this is an interesting one. There's not much data on this one, but obviously we have one that does work. The data set for NFPA, for example, we can see a control valve item activity, which has a specific location. This will probably tell you where the item activity, pump room, backflow, city side on the ground floor. So this is all the information you can find. And since this is a live demonstrator, so if they're in the audience and people who are interested in looking at specific items, then please put that in the question and answer setting, and we can show that. Is there anything else, Victoria, that I should show that we should go through?
I think it might be interesting to look at it from a from an item perspective or from a deficiency perspective, and trace that back to look at some of the deficiencies and the details provided on that.
This one is interesting. So here we have a deficiency that said does not activate when tested, powered by supply in B1. So there we can see on which item it is. And then we can see in which, I can actually see the manufacturer is that, and then we could actually look at, oh, there's 1,000+ items from this manufacturer. And this way you can basically browse through, you can browse through all these items. That's what you talked about, Victoria?
Yeah.
Okay, perfect. Yeah, I think we're open for questions.
Yeah, thank you for the demo. And please write your questions in the Q&A, and we will try to answer them. Well, I have a question. You talked about the difficulties in getting data, and can you elaborate that? What do you think? What is the barriers, and if you were given the chance to persuade me, for example, to share data, what would you say?
Oh, there's a lot of different answers to that question. Let's talk first about the issues we had with getting the data. So there were a lot of parties who said, "Oh, we are certainly interested in helping this research project because it was a research project. So tell us what you need, and we will provide that." That was easier said than done, not from the good intentions, but as you can imagine, if you talk about inspections, and there was a lot of contractors in the US who were interested in helping out with this, but there is a lot of competitive information in there. So the sites they check, so that could be potentially be problematic if they share this information. So we were confronted with some legal departments who said, no, you cannot share anything, et cetera, et cetera. So that was sort of the first part on getting to, that the ability to share data. And then secondly, okay, in what type of format? How does it come? Sometimes we just got a report. This is the amount of inspections we did. It was, well, great, but it's not what we want. So we want more detailed information. And then we ended up that people were doing exports from their systems internally and say, oh, here's the data. And then it was completely unclear to us what it was about. And then later on in discussion with them, it was even unclear to them what they've shared. So these are all the sort of the more practical problems we ran into to get the data and to deal with it in a form that we could actually understand what it was about and how to relate it back to, in this case, the NFPA 25. And that was one of the conclusions which I shared, is like NFPA 25 was never created with data collection in mind. So the liberty people have to interpret this on how to record the data is pretty broad, which made the explanation for the different formats we got. So that is more the technical one. And I think the other one, why do you want to share your data? Why would it be a good idea to do this? First of all, is from my perception as an outsider on, for example, some of the intervals which are in this case, the NFPA 25, it's not a performance-driven interval. It's more like, should we do this 3 months? Should we do this 6 months? Raise of hands for 3 months, raise of hands for 6 months. And that was sort of the source of the decision. I say overly simplify it like this, but sometimes these intervals were like that, which basically means that you as a building owner are doing inspections at intervals, which were sort of, well, by raise of hands determined. Wouldn't it be nicer if this was done on data-driven, performance-driven? So how many times do systems actually fail? To be able to make data-driven and performance-driven decisions, you need proper data. And you cannot have it from, if you want to do statistical analysis, you cannot do it from a simple set of buildings. You need to have a wider set of buildings and installations covered to do some statistic relevant analysis. So that's to help create these data-driven intervals. You need to share your data, otherwise it is not possible. That was sort of the predecessor of this project. Maybe Victoria can actually sort of do some background on what projects were ahead of this one.
Yeah, I think you covered a lot of the key points. To the first point that you mentioned about the challenges of getting the data, another thing that we heard that I'll just add is the time that it took the facility owner to compile this data to provide it to the project, right? If it's not in a system where they can easily just export the data and send it to us, they had to take time away from their jobs and their normal day-to-day to provide us data for this purpose. And that was one of the largest barriers, is they didn't have the staff or the capacity to provide us that. So I just wanted to add that other item in there. You know, on the performance side, we have done several other projects on this topic area around ITM data collection and analytics, which kind of led up to why we stepped back and took this approach with creating a data model, because we were trying to just collect data from people, compile this data, and see if we could, you know, determine what the appropriate frequency was based off of this historical data. But the quality, you know, was not consistent. The quantity of data was not consistent. It wasn't easily combined for analysis. It was very time consuming to do that process. And then just the overall quantity of just trying to manually bring in data this way made it very difficult, and we weren't able to do it on a large enough scale to be able to really do the performance analysis that we were wanting to do. So kind of what this data model is intended to help us do is to get everyone on the same page in terms of data and understanding what the data means, so that we can scale it up, kind of have a common means of being able to contribute and understand data to enable us to do those performance analyses in the future. But one thing that, you know, I think in terms of the future, as we start having more and more smart systems and start having systems that can automatically capture and report data, that's going to really take us a long way in terms of being able to do more performance analysis. Because right now, a lot of the data coming from fire protection systems from these ITM activities, it may only be one data point per year or one data point every 6 months. And when you look at it from a data and analytics perspective, you need a lot more data to really get, you know, kind of that analytics driven perspective. So I think as, you know, the smart systems and fire protection start to merge more and get to a point to where we can get data out of these systems, you know, at very short intervals, then I think that kind of opens up the doors to what we could do in the future. And I know, Bart, you did create some alignments in the data model to where, you know, it's built with that in mind for, you know, future modifications.
Yep, that's correct. Yeah, we created some alignments with sensor network data. Not that we found any of the data that actually aligned with that, but for the future that could be one of the possibilities.
Yeah, thank you. Have you bumped into any questions about cybersecurity and whether this sharing can actually open up holes in the safety and security systems?
It hasn't come up specifically in this project, but at the Research Foundation, we have been doing some work on cybersecurity for fire protection systems, looking at the vulnerabilities. And that is one of the things that came up, is any kind of connection, data reporting, export functions where you can connect a laptop in and get data out. Any of those connection ports, it does introduce a vulnerability, but we are kind of scaling up the cyber protection of systems. And luckily, we haven't really seen any major incidents in fire protection systems for cybersecurity, but it's definitely something. I think the NFPA 25 committee in the US, they are considering cybersecurity going forward. So I do think it's something that's on the radar. But as we start to get more interconnections and data reporting and all these things, I think cybersecurity requirements are going to move in lockstep with that. Just because we can't afford to have these systems compromised. So it's definitely on the radar, even though it's not a huge issue yet. I think it could be in the future.
Yeah. Thank you. I'm getting curious about what you can use the model for. Can you kind of look at a specific manufacturer's component of some kind and see if you have a lot of failures on that, and on the other hand, if it's very good?
Yeah, yes. Not by point and click, but that would definitely be a query you could do and say, okay, give me from a certain manufacturer, give me the rate between deficiencies and or fail and pass, basically. That's perfectly possible with this, and what type, and categorize that by item type. So categorize that by pumps or sprinklers, or because, well, there are relations in both directions between the items. It's fairly easy to create a report for that from this data model. It's not that we could quickly click that together, but it can be done from the data model. Yes.
Okay, thank you. I had one question about you using the URLs. How to keep them valid? Normally people change URLs quite often.
Yeah, that's a very good and ongoing debate within the linked data community. There is a whole document on creating persistent URIs and having a I just came up with the Dutch name. I need to translate it quickly. A URI strategy within your organization on how to do this. It is important to recognize, though, that to make this analysis work in a system like we show here, it doesn't need to be published per se. So it doesn't need to be available on a specific location. Although that is obviously it is advised to do that, especially for the vocabularies what we create. And you can see that there's quite a bit of vocabulary, stable vocabularies published this way, so that you can look at the data and say, oh, I understand what this is about. So that is definitely something that you need to think about, and that's also one of the reasons that we talked about it. A data steward or a data standards committee who's looking at these specific characteristics of data models.
Okay, thank you. Okay, well, no more questions right now. Anything else that you would like to give attention to here? What have been your experiences so far, and the next step? What do you do next?
Well, one of the questions we have is what would be the proper location to host such a data model, and more as as host and host organization. So we've been looking at, we've been talking to NFPA, but they're not a data standards organization. They're a code and standard organization, but a data standard is something completely different. I have a lot of experience at W3C, the World Wide Web Consortium, which published a lot of standards on which the web is based. I'm active in some link building data domains because I think this is completely related to BIM and all the other types of models, which are using more and more linked data as well to be more interconnected. But if any of the attendees has a good idea where this could be hosted, I'm really open to that.
Yeah. Would it be possible to do like a pilot in an isolated environment? Let's say one building owner with a lot of buildings or facilities that would just set up a model for their company. Would that be possible?
Oh yeah. Essentially, that's what we've done here. We created and anonymized a couple of data sets from the various suppliers and put that here. So nothing you see here needs to be public. I mean, it is public for the demonstrator effect, but there's by no means that you need to do this out in the open. This can be completely run internally and use the data model because it gives you the ease of going through the data from every different angle you can think of.
Okay, thank you. So we have no more questions from the audience. Anything else that you would like to add?
The only thing I would add is, a lot of the past projects that we've done has been focused on trying to do the analysis side of this. I do think we've made quite a bit of progress here. So I think this does kind of open up an opportunity for us to take some of the data that we've gathered and even try to gather even more and look at it from an analysis and performance perspective. To get back to some of those original goals that we had of better trying to understand the reliability of some of these systems. So that's something that we'll consider in the future, as well as seeing what traction we can gain in terms of turning what we've developed here or having it reviewed by a committee to develop it into a data standard, because that would really help carry it forward in terms of being able to standardize ITM data on a large scale that would really support further analysis. So those are two things that are kind of on our radar moving forward.
Yeah, very good. It really, I think that it really puts it in a good perspective of how important this is, and I think we will see much more of this in the future. So thank you very much. I will just wrap things up and tell you a little bit about what's next at Brandforsk. So thank you, Victoria and Bart. That's very interesting. And we have more webinars coming up. We have one more this year. It's about fire safety and cultural heritage, and it will be in Sweden. It's in Swedish in 2 weeks from now. And we're also already planning the webinars for the next season, and we are starting in January. And if you want to keep up to date, you can apply to our newsletter, or you can follow us on LinkedIn, for example. And if you have missed any of our earlier webinars, you can see them on our webpage or in our YouTube channel. And you will also, of course, be able to see this webinar in a few days on that channel as well. And before we close, thank you again, Victoria and Bart. And also, I would like to thank my colleagues, Francis Eurenius and Matthias Hammarin, that have been producing this webinar. And thanks, of course, to all our supporting organizations. And please answer our questionnaire after the webinar. That's very valuable for us. And I hope to see you again soon on our webinars. And also, of course, please feel free to get in touch with us. And you will find our contact information on our website. And you can also find the contact information for Victoria and Bart on the webpage for this webinar. We will be adding those very soon. Thank you very much. Bye-bye.